So we're gonna branch off a little bit, right? Watch. We're gonna, when we differentiate, when we make a distinction between these two probabilities, watch what I'm gonna use. EP for experimental probability, theoretical, it stands for TP, right? Watch this, a probability of an event A occurring based on trials, right? So experimental probability is based on trials, experiments, or surveys. When they do surveys, they do that to figure out a probability, whether you know it or not. So experimental probability is based on number of trials. Okay, versus I'm going to use a different highlighter for theoretical. It's based on possible outcomes, right? Number of possible outcomes. I don't want you to use this as an explanation, but this is going to help you maybe. This is experimental is what happened, right? I'm going to say based on what happened. And this one is what should happen. So experimental is based on what actually happened. It could be a lab, it could be surveys over the internet, right? You get bombarded with those these days. You can't do anything these days without somebody saying, hey, you bought this, can you please answer? Take 5 minutes to answer these questions, right? They're surveying you all the time, right? They're calling you, they want feedback, right? And that's to come up with probabilities. So watch this. Experimental probability is the likelihood of someone having a certain blood type, for example. That's not based on theory. That's based on actually what they're observing, right? A likelihood of a team winning a game. That's based on what the team has been doing up until that point. Likelihood of someone voting for a certain candidate, right? That is based on them surveying people, asking for, like polling, right? We call that. Based on theoretical, that's what we've been doing a lot, guys. When we do cards, dice, anything like that, that's based on theory. So it's the likelihood of someone drawing an ace from a deck, or rolling a 5, or spinning a spinner, and so forth, right? So there's a bit of a difference there, and just make sure you understand that. Watch the next part here. This is very important to understand. In general, when we perform experiments involving events where there is no bias, right? When there's no bias, the EP should be similar to the TP, right? The main reason they may be different is because of a small sample space. Please highlight that as well. A small sample space. This is what a small sample space is, okay? I don't know which side to start, but are you a Jets fan? Yeah? Bettina, are you a Jets fan? You're not interested? Okay, so I'm done my survey. I believe that 50% of people are Jets fans and 50% are not Jets fans. Is that accurate? Terrible. 2 people, so small sample space. Even this class is small, right? If I just surveyed this class and it said Sisler, therefore, is divided in this percentage, not true, not accurate. So a small sample space is a big problem, right? So small sample space, experimental will not be the same as theoretical. For example, right? If I have a deck of cards, I still have time. I want to make my point, right? If I have a deck of cards and I'm drawing, right? I'm drawing a 7 of clubs, right? Chances to grab a 7 of clubs are what, in theory? Just randomly grab this specific card would be 1 in 52, right? Will that be accurate if you just pull like 3 or 4 cards? Will that actually resemble that theoretical probability? Probably not. No. Even rolling dice, like if you just roll it 3 or 4 times, the theoretical probability of 1/6 is not going to be accurate because your sample space is way too small. You need to perform like a couple hundred rolls or maybe a couple hundred draws, right? And then you're going to start seeing, hey, that's actually true. In general, that's what's happening, okay? So small sample space, large sample space, then the experimental is close to theoretical or sometimes exactly the same, okay? All right, next. This is very important to highlight. I will actually highlight this box because I'm going to ask in some sneaky way, I'm going to ask you if you understand this, okay? Note, when making a prediction, right? When making a prediction and you know both probabilities, we use the theoretical probability to make a prediction, okay? You do not use the experimental, you use the theoretical if you have both probabilities. Why would that be? Well, the experimental probability is probably off, so it's always safe to go with the theoretical because mathematically speaking, it's going to end up being that in the long run. All right, let's keep going. Follow me closely, please. All right, if you want to understand this, a bag contains various letters as seen below. So this is the bag that we're drawing from. Look at that. I made this by hand. All right, Alex draws a tile, records the results, then places the tile back in the bag. The process is repeated 8 times, right? I'm repeating this process 8 times. Here are the results. So 1, 2, 3, 4, 5, 6, 7, 8. These are 8 experiments. I'm going to write that figure, 8 trials. Let's do trials. These are not experiments. It's 8 trials, right? 8 trials, and I'm going to do this, right? Now, state the experimental probability of drawing the letter A. So because now it's important to distinguish, I'm going to actually go like this. Experimental probability of drawing a letter A is, question, are we going to base our answer on what's in the bag or are we going to base it on this? We're going to base it on this because it's the trials. So how many trials? 8. And right, 8 trials. I'm going to actually write that down like that. And how many times did you get an A? 1, 2, 3, right? 3 A's. So I'm going to go 3 A's like that. So your probability ends up being 3/8. And that actually is 0.375, right? I'm just going to go here, match my key to where I'm at. That's 0.375 or 37.5%. Okay. Next, state the theoretical probability of drawing the letter A. So TP A, right now it matters. It matters what your answer, how you're answering, right? Pay close attention to what I'm saying next. Theoretical probability, we do not care about the experiment. Who cares? Good job, you did it 8 times, whatever. You're gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total is 10, right? Total is 10 letters. So that is the number we're going to put down here. In theory, there are 10 tiles in this bag. How many A's are there in here? 1, 2, 3, right? There's 3 A's. 3 A's, right? In bag. In bag. 3 tiles in bag. Okay? I'm going to actually make an arrow, go from here. And let's make an arrow from up here. Right? So you understand, hey, in that case, I based it on the trials, and the theoretical part, I don't care how many trials. I based it on what's available to me. There are 10 outcomes possible. So we go 3 over 10. You know this one, right? 0.3, which is 30%. Do they match? No, they don't match. Okay. Why is the experimental probability different than the theoretical probability? Right, so we just go under this, we'll go, why is the EP different than the, right? Why are they different, right? And you will make your decision based on the trials, right? This is due to the low number of trials, right? Alex needs to increase the trials so that the theoretical probability will be similar to the experimental probability. I will say this in brackets. Basically, what we're saying here is increase the sample size. Sample size. Yes, there's only 10 tiles in there, but that doesn't mean that having 8 or 10 trials would be enough. You'd have to do maybe 100 or 50, and then you're going to start seeing a resemblance. Every question here matters to set you up for the work, okay? If Alex would draw 500 tiles, how many times would you expect to draw the letter A? Right? You're making a prediction, correct? Prediction. Which probability would you use? The theoretical or the experimental? I actually told you that on the previous page. I'm just checking if you're awake. You always pick the theoretical. When you have the choice, you pick the theoretical. If you don't have a choice, if they only give you this, then you use this one. But so we go 3 over 10 times 500. And that's actually 150 times exactly, right? Okay, I'm going to make a note here. Use theoretical probability. Exclamation mark, exclamation mark, exclamation mark. Keep going. No, I'm just there. That's good enough. State the experimental probability. What's the experimental probability of drawing a letter B? Then the theoretical probability of drawing a letter B. The odds as well. I want you to do the odds as well right next to it. Since we're almost done, I'm going to let you do this. Take a minute or two, answer that. Could you do that after my lesson? Just it won't be done all in class, right? experimental probability of, right? So I would strongly encourage you to do that. We still base it on the 8 trials, right? How many times did he grab a B out of the 8 trials? Just once, that's right. Let's write the odds. So that would be 1, 2, 8 minus 1. So it'd be 1 to 7. Right? Just practice that. We don't want to forget about how to do that. The theoretical probability of drawing a B in this case, we have 10 tiles possible, right? 10 outcomes that are possible. And how many B's are in there? There are 2, yeah. So that would be 0.2, 20%, right? We won't worry about that right now. Odds against, whoa, what's that? Forgot about that. Odds against means you're going to put the 2 here, and this is going to be 10 minus 2 over here. So it's 8 to 2. Because it says against a B, basically. And this is going to sound a little outrageous, right? 28 to 38 homework, what? Okay. I would say this, you decide how much you need to do. I will post the entire 10 pages. I don't think you need to do every single one, but I do think you need to do some here and there. Look at the key, right? See if you understand how I came up with the answer. And the rest is up to you. So I will expect you to know this by tomorrow for a short AC, okay?